begin with the first major topic that we take, something called the compounding frequency. Now, a lot of the times interest is paid on instruments at a frequency which is more than once a year. Many banks offer monthly interest rates which get compounded 12 times a year. However, rather than quoting the monthly rate, they effectively quote the annual rate. This rate is known as the effective annual rate or the stated annual interest rate. So if a bank effectively quotes a 12% stated annual interest rate and is compounding it on a monthly basis, what ends up happening is if you invest $1,000 into the bank account, every month this will grow at 1% and you will effectively compound it 12 times during the year, if it is a monthly compounding process. Fine. If it is quarterly, you will take the same 12%. On a per quarter basis, you are effectively earning 12% divided by 4. So in the case of a quarterly scenario, you have your $1,000 multiplied by 1.033% to the power 4, because you have 4 periods which are giving you 3% rate. So how does this look like? If I could share a small Excel file with you, you will note that this will appear to be something like this, where we have taken the same 12% interest and effectively, let's say we have deposited $1,000. So what you see here is the 12% interest. We have deposited $1,000 each in 3 different accounts. One which gives monthly, one which gives quarterly, one which gives semi-annually. In the case of monthly numbers, we just have to take the stated annual rate or the quoted annual rate divided by 12 and assume that interest gets compounded on a monthly basis to give us the final return. If it is quarterly interest rate, quarterly compounding, then effectively we have to divide this stated annual rate by 4 periods, because there are 4 quarters in a year, and compound the rate based on that, which gives me 12.55%. If it is semi-annual, twice a year, effectively 6% return gets compounded twice during the year, and that gives me 12.36%. More the compounding frequency, more the annual effective return. So if the compounding frequency increases further, your effective return will be higher as you keep earning interest on interest. Fine. So that's the portion on compounding frequency that is important. Let's go ahead and quickly look at some of the other concepts within the time value of money chapter. So that's the compounding frequency bit. The compounding frequency, effectively, you could come up with a standard formula for this, which essentially says the present value of the quoted investment, which is $1,000, multiplied by 1 plus whatever is the annual rate, in this case 12%. Let's assume we are talking about monthly numbers, so I divided by M, which is the number of periods or the frequency, the number of times that you are compounding it during the year, multiplied by 12 multiplied by 1, because 1 year has 12 months effectively. So you get 1000 into 1.01 to the power 12 effectively. So that's the answer to the compounding frequency question that we take. Fine. Let's move ahead. If on the contrary, now you assume that the interest rate compounds every instant. It is continuous compounding, which means every second, every moment you're generating interest, and you're generating interest on that interest as well. This is known as continuous compounding, where effectively you are putting it to the power of E. So E to the power 12% multiplied by 1 period, 1 year. That's your value that you will get. You will note that just like we have earlier discussed, continuous compounding will give you the highest effective annual interest. We said higher the frequency of compounding, higher the effective annual interest. If the compounding frequency is continuous, which means it gets compounded practically every instant, this is the highest return you can generate on the funds that you have invested in this particular portfolio.